Hello again. Tonight we're going to talk about places where you can have your planet with your life on it being within a solar system, a stellar system, and where that stellar system would be in a galaxy. So stellar and galactic. Stellar refers to a solar system. In our case, the Earth is as they say, the third rock from the sun, about 93 million miles from the sun, and we're between Venus and Mars. And we're in that habitable zone, also known as the Goldilocks zone, such that most of the water on our planet is liquid, aside from the clouds, which are vapor, and the frozen ice stuff, like down in the Antarctic. Galactic refers to a star system within a galaxy, like the Milky Way, and we're orbiting about that supermassive black hole at the center of our galaxy. We're about 26,000 light years from that black hole at the center. We're within a spur. Now, it's the Orion arm, but as you can see in the upper right, there's a little gap in there, so they're referring to that as a spur of the Orion arm between the Perseus and Sagittarius arms of the Milky Way. We are far enough away that we're safe from most emissions like quasars and stuff like that, or from expulsions like things getting slingshotted out of the galaxy. We're far enough away to be safe from that. Now, when they talk about the habitable zone within a solar system, that's literally referring to based upon the particular temperature of the host star or the parent star of the solar system and how much energy it puts out, how far away would the planet need to be so that if it had water on it, the majority of that water would be in a liquid state so that you could have like oceans and clouds and reasonable environment for life to exist. If you're too far in, then all the water gets cooked off and you have a dry, dead world, kind of like Mercury is within our solar system. If it's too far out, then you have icy things like Pluto, where it's so far away from the sun that it can't get enough heat to have anything other than frozen stuff. And also in a galaxy, if you're far enough away from the center, you're going to have fewer impactors or radiation incidents from pulsars or quasars or novas or supernovas. And it gives whatever is living there more time to progress and develop technology. It's better when it's a spot within a solar system where it's habitable due to lots of water. And it's better when it's farther out in a galaxy so that it doesn't have to defend itself all the time and have resets. And it needs to be sufficiently advanced. So just having a place that's good for life and protected within a galaxy, you need a long enough period of time so that whatever evolves there or grows there or finds itself there can develop the science and technology so that it can reach out, communicate with, initially explore its own stellar system, then its home galaxy, and at some point in the distant future, maybe other galaxies in the universe. So one of the other things you have to deal with is not just communication, but propulsion, because you might be able to, use the radio spectrum or lasers to communicate, but eventually you're going to have to realize that doesn't go well enough, doesn't penetrate well enough, and you might have to learn how to modulate gravitational waves, which travel the universe. So they're better at communication, just as we stop using smoke signals because we found that modulating the electromagnetic spectrum was better. And here's something that people just presume, that when we put out probes in space that we can see everything, or that we can see sufficiently small detail to know what's there. And that's just not the case. An example here is you could put a double wide sized trailer building on the moon with a 50-foot dish antenna on top of it. And the best thing that we would have is the Lunar Reconnaissance Orbiter's synthetic aperture radar, which would be capable of each pixel discerning something roughly 90 feet across. So a double wide trailer with a 50-foot dish would not even be a single pixel within the image. So you can have sizable stuff on the moon that we don't know is there, even with the best stuff we have currently orbiting the moon. Not that you have to see it from like the Hubble Space Telescope in Earth orbit, but you can be in orbit around the moon. The resolution is still not detailed enough for you to spot even rather sizable things. So for them to see like the rover tracks, there's a lot of interpolation going on there. You can't see detail within the tracks, but you can see the width of the tracks, and they'll fill in some pixels. Regarding Mars, Mars Reconnaissance Orbiter, the MRO, has a better camera system called HiRISE, and it can see down to 1 pixel is 3 feet. The rovers that are on Mars, it can see the long tracks from them, and it can see like a pixel where the rover is, but it can't make out detail on the rover. The only way we're ever going to get higher resolution than those is if we land on the moon or we land on Mars. The other thing is you have to be able to see through dense atmospheres. Venus, Jupiter, Saturn, Uranus, and Neptune, and some of the moons of the outer planets all have dense atmospheres of different contents. It could be hydrogen, helium, methane, ammonia. We don't have any ability to see through those optically. We do have radar images of things like Venus, but their resolution is relatively low, and the color spectrum is fairly narrow because in radar, we're not seeing in actual color, we're seeing in grayscale. The other thing is that the cameras that we use, the images that we get back, let's say in infrared, there are objects that would be too cold for us to discern detail, even in infrared images, because our infrared is near infrared and medium infrared, that's NIR and MIR, but we don't have any instruments out there that will do far infrared, that's FIR, and the infrared imaging that we can do compared to optics is fairly low resolution. But the magnification scale of things like the James Webb Space Telescope is such that even with a couple of thousand pixels by a couple of thousand pixels, that's relatively low resolution for something that's so far away. So when we look at, let's say, a James Webb Space Telescope of a smaller moon of Jupiter, we can't make a lot of detail out. We can make out its brightness, but in reality, we can't make out even how round it is. And that's just in the solar system. And also, we can't observe beneath the surface of pretty much anything aside from the synthetic aperture radar. The moon, Mercury, Mars, and asteroids, they have thick surfaces. They're rocky, or they can have subsurface caverns and lava tubes. And in the case of some of those moons of outer planets, they can even have ice-covered deep oceans. We don't have any ability to see beneath those surfaces to see what's down there. We currently have Earth-orbiting satellite technology, so we can see subsurface observations. You've probably seen those of scans of like the pyramids in Egypt and places like that, where you can see what would be subsurface differentiation in materials, but you can't see details. You can make out like what might be a column versus what might be a rectangular cube-shaped chamber, but you can't see any details on the wall structures or tube structures or levels of them. So just interpolations or approximations. But it would be interesting to see if we took that synthetic satellite technology and put it in orbit around the moon or Mars. Maybe then we could see some of these subsurface features. Until we make the investment, we won't know for sure. So here's how it all ties down into whether or not we're alone in the universe. There's this thing called the Fermi Paradox that says, I know that the universe is big and there's a lot of stuff out there. And now that we know there's a lot of galaxies and a lot of planets around all those stars. And, we found habitable zones around planets, around stars that have planets in them. And now we're finding that some of those habitable planets have gaseous atmospheres, but so far not human compatible. That must mean there's got to be life out there somewhere, but so far they're not knocking on our front door, so maybe they don't exist. That's a possibility. It's like saying the Europeans that came over to North America might not have known North America was there or how big it was because they hadn't been there. So until we can start actually getting more detail of stuff out there, sure, you can state the Fermi Paradox is the statement why we haven't detected any other life elsewhere in the universe. There are other reasons. So that there's no one else out there in all that space and all those possibilities, maybe they're just too far away from us to communicate using radio technology, or maybe they're not sufficiently advanced to have radio technology. Or even if they had radio technology, maybe they're just so far away that the time lag at the speed of light means they haven't been able to talk with us yet. There are planets around stars that are a single digit number of light years away from Earth. We haven't found any habitable atmospheres, any human compatible atmospheres yet. So it's not that they aren't near enough that radio wouldn't work. It's that we haven't found just the right planet at the right distance. But I think the big thing here is if we constrain the universe, despite its vast nature, to no more technological progression than we currently are at, no light speed communication, no light speed travel, that must feel really good as humans to make us feel comfortable in our egos, but it's just not realistic. We're already investigating the potential for travel and communication that would exceed light speed or be more reliable than electromagnetic radiation, radio and lasers. But why would we hold out that places in the universe other than here couldn't have already developed the stuff that we're just looking into? I think it's more that the universe is filled with technologically advanced sentient life. They've conquered the communications of the limitations of radio communications and space travel at light speed, and they're actually not discernible by us because they're sitting out in the outskirts of our solar system, maybe in the Kuiper Belt, maybe in the Oort cloud, and they're watching with advanced technology. They could be doing this for countless worlds. This is what the zoo hypothesis tells us, is much like a hunter in a blind who's observing for the sake of observing, not for hunting. They could be sitting in a blind and the creatures would be oblivious to them being there. Seems more plausible given how old the universe is versus how young the Earth is, and particularly the life that's on it. If we said the universe definitely has life in it even before we prove it, then that would maybe make some people not comfortable. But if you look at human history, fear makes us vicious. I don't know how much fear I would want to instill in the wild animals. I would say, if you're out there, at least for now, keep your distance. You can look, don't interact. So there is this thing that says, well, the whole reason for the Fermi Paradox proving itself out is the great filter. This is that there's something about advancing or progressing life on a planet or their technology that you're just never going to be able to conquer it. It's the ultimate intractable limit that will stop you from progressing any further. So as a society, a species gets older and older, they'll eventually encounter the great filter and they won't be around anymore, which kind of culls the more advanced stuff. So that's why we can't find them. They may do themselves in early, like discover nuclear fission, start a war, and then end themselves. Or, hey, it's cool, let's generate a black hole. They start one and end themselves. Or they're just a little slow and they never progress technologically enough until 5 billion years into their existence, and all of a sudden their parent star goes nova or supernova before they can find a way to communicate or to leave their planet. So what's the best way to deal with this intractable limit? Species-wide educational. Teach everyone on the planet about what they need to know. Get more minds cooking on the subject. Teach them the ability to think outside the box, go outside the box, go off the rails occasionally. Teach them how to bring it back in with rational thought, debate, reasoning. Do teach the scientific method for progressing past those issues. If you find a problem, find the root cause of it, analyze it, create a workaround, create new technology, progress, and point out that every sufficiently educated mind is valuable towards solving the issues. And you never know what issue you're going to come across, so it's better if everybody is more educated. And do try to stem our animalistic behaviors. I think that if you have a species-wide educational system, it's going to make an environment where behavior beyond the norm is more readily recognized, and there's more disdain shown for it, and you'll pull things back together and progress. War is valuable only to those developing and producing the weapons, and anything that destroys is damaging to others, and that domination is not the answer. Of course, that's my, as the saying goes, humble opinion. So in summary, if you're asking, if the universe is so big, where is everyone? Well, the universe may be big. There may be lots of stars, galaxies, and planets, but start narrowing down, filtering things to the point where you find places where sentient life can take root, progress far enough, survive long enough to communicate out into the universe, get out into the universe. So narrow those potentials down, and don't start with the stuff that's thousands to millions to billions of light years away, because they might find a way to communicate with us, but if it's not radio or laser, we don't know that they're talking to us, and we have no way of communicating back. So let's start with the nearby stuff first, and don't constrain the limits of progression of technology. Out of the 4.5 billion years that our sun and this planet have been around, we've only progressed technologically a couple of hundred years. Not just electronics or computers, but even mathematics and developing things from physical measurements and repeatability and stuff. We're only a few hundred years into that being officially recorded technology. There are other planets in a galaxy that we know of, like one of the ones 4 or so light years away, that have been around for maybe a couple of 100 million years longer than the Earth, and therefore might have a head start. And remember that the sentient life on this planet has endured 5 hard resets, extinction level events that narrowed us down to maybe only thousands, and we've had to work our way back up from then. I remember us doing the how many times have we learned that the Earth is not the center of the universe, and we're on number 4. So give us a chance. We keep restarting. And communications is currently light speed constrained, and applying that restriction to everyone else in the universe, I think, is just plain dumb. And our current space vehicles are chemical propulsion limited, and applying that restriction to everyone else in the universe is also just plain dumb. So keep progressing, keep the education up, keep observing, set aside whether or not they're out there, just keep progressing technologically. And once you hopefully have enough education, you'll calm your animalistic urges, and either they'll find we've passed the indoctrination test and they might come knocking on their door, or maybe they're already here saying, we're here, we're showing you ourselves, how come you're not seeing us? Or we'll spot them first and let them know through our primitive radio means, hey, we see you. Or maybe we'll advance far enough that we'll go knocking on their outpost door, either in the Kuiper Belt or the Oort cloud. And a few links. Comments? Question?
Yeah, why do we have to care if there's anybody else around?
We actually don't. We just have to keep progressing our education, our civility, and our observing. We're just there trying to, we are the universe discovering itself, that, we are an individual. We have self-awareness. Think of it as, yes, the universe is vast. We are what we are currently. We'd like to be better than we are currently. The thought that we have a good bead on things technologically or understanding the universe, we are far short of truly fathoming what's out there. That shouldn't stop us from realizing that we are of value in the universe to discover more about the universe. We can consider ourselves as small compared to the universe, but small also means unique. If in your day-to-day life, you don't spend any time thinking about things outside of your day-to-day life, you're fine. The universe will go on despite you paying attention to it or not. You can still exist. Your life doesn't change. Think of it on a smaller scale as there are many millions of websites out on the internet, and you don't have to pay attention to all of them, but they still exist. Same thing for the universe. There are billions of stars just in our galaxy, and there are billions of galaxies. You don't have to be aware of all of them. You don't have to compare yourself to all of them, but they can still exist. Well, I did a presentation a couple of weeks ago about the fact that technology is advancing faster than the individual can keep pace with it. There are things that are beneficial for the individual to be aware of that might help them in their day-to-day life. People do accommodate those despite the fact that they don't understand the underlying technology. You grab a mobile phone, you send a text message, you don't need to know how it works. It just works, and that's fine. Your mobile phone rings, and you answer the call and you say hello and you talk to someone because you see who it is on the phone. or maybe you do a video conference call. You don't have to understand all the minutiae of the technology that makes that work. The same thing is for the bigger things, like you don't know how you need to know how the James Webb Space Telescope maintains its orbit around the Lagrange point 2, but it does. And there's always a small cluster of people on the planet that do have to pay attention to all that technological minutia and do have to get it right in order for it to be successful. And they do focus on things that we haven't thought of yet. They're the cookers, the creators, the people that do come up with what's next. You don't have to understand everything of what they're doing. There are a lot of scientific research papers published every day. You don't have to be aware of them. You don't have to understand the underlying mathematics or physics. You don't even have to know they exist. But occasionally they will cross into your domain. So if you're an amateur astronomer, something about black holes, or hey, they think they found a mid-sized black hole and they're waiting to confirm it. And they, well, that's just the announcement. Let's wait for the peer review. And the peer review comes back and says, well, not exactly a middle range black hole. It's more of a edge of the middle range. So good find, but not yet. Or you might find, hey, look, there goes an asteroid through our solar system, but it didn't come from our solar system. If it went through and there was no media talking about it, you'd never know it went through and you wouldn't care. That's fine. You don't have to be aware of everything. That's my job. But even I'm not aware of everything. Sometimes I have to go do research. That's fine. So the fact that an individual doesn't know everything is normal. That's learning the basics over again may have happened multiple times on this planet, and we would have no evidence of it. But remember, it's like a buffet. You can go to the buffet, eat what you want, and don't eat what you don't want. You can, if you're hungry, eat all that you want, leave the rest. The technology, the advancements, the universe, they're like a giant buffet. If you're interested, learn about it. If you're not interested, or like, that sounds complicated, set it to one side. Okay. Any other comments or questions before I stop recording? Hearing nothing.